All right, so let's now look at different problems as examples to show how we can find confidence intervals to estimates. A population mean value. And so now let's look over to my computer screen here. Let's look at our first problem as an example. So as now we spent some time reading the wording description here. It says our obtained sample of gas prices on June 1st, 2020 had mean $1.69 and standard deviation 0.25. So with this very beginning statement of our worded description of the example, anyone viewing this video is going to be very curious of what sample am I talking about. So here's the sample again. And I brought this up for anyone viewing this video to see that you can work, in case we work completely with any problem of finding confidence interval in Scratch. And here's how we start. We always start out having a sample. So right here is a sample of gas price that I randomly collected on June 1st, 2020. And so if we can quickly spend some time counting all the gas prices I've made. We got some repeats here, a few repeats of gas prices, and these gas prices, by the way, they came out from the different random cities that and quite nationwide, and once again they came out from random cities that was collected throughout the entire nation, our United States here. And so quickly counting through here, we can see that we have 36 prices. But then let me now also remind you that so I did the calculation of the sample mean value. So this mean value here is right from this sample. But in case anyone viewing this video is intending to really work side by side with me on this example, on this problem, as a pretend that you are working completely from scratch, then here's how you can. I mean, I'm not the only one who can calculate this. You can do this as well. Here's how you can do that on your standard TI 83 and 84 calculator. You can just simply recall that I've had a lesson showing how to use the stats button right here for entering data and calculate quickly mean value and standard deviation. Now we can use all that. We can put all that skills in good usefulness here. So we can go stats, and right here under edit, we can select edit. So I already had the complete data set right there, enter. So these are all the values in the data set already being entered. And I chose column L1 in my stats list, but you can choose other empty ones if you would like to. But now once we've had the data entered, then recall that we can just click stats again and turn over to the calculation submenu. And right here with one variable stats, we can quickly hit enter. Now, so I put my list in list L1. So here I'm just giving it L1 in case you put your data in other list L2, L3, for example. Then we can go second, and with the corresponding number. So for example, second 2 is to retrieve list L2, or you can go second 1 to retrieve list L1. Actually, let me clear that out, and the second 1 to retrieve list L1. So, and then quickly click calculate. And so now that's how we can, and again, if you are really working as a real statistician, as a real professional working on this, then that's how you can quickly get the sample mean value. So right here, that's how it agrees with my sample mean value that I have already calculated here. And so the standard deviation here is also, notice how I use the lowercase letter s right here, because this is only the standard deviation from this sample specifically. So it's a sample standard deviation. So looking back at our computer calculator screen, then the SX right here is the value that I looked at. So 0.25 is our sample standard deviation. And this stats button right here, this stats command, this one variable stats command is also powerful enough to also quickly give you the count. So earlier when we were looking on my lecture notes, then I was counting out I was asking viewers or to count by spend a few minutes counting, but indeed we actually don't need to do this as well. Once we can just spend sometimes inputting this data into the calculator, then the calculator can quickly count for us how many pieces of data available in our data set. And so now that everyone is agree that the sample we're using is having all these characteristics right here. We have a sample size here, n equals 36. We have a sample mean. That's why I used x bar here. So x bar equals 1.69. And then sample standard deviation equals 0.25. So the sample itself and all of these characteristics of your sample are all considered as given information. So now let's get back to the actual question of the problem right there, the actual instruction of the problem as example 1 that we're doing. And so now let me continue further. So now we want to construct a 90% confidence interval. Okay, and so now I highlight this term to make it consistent with what I've mentioned in my general lecture, that anytime we're working or about to work with a confidence interval problem, or then we will always be given a confidence level. So as our goal here, we need to construct, or sometimes we can call that we find a confidence interval. But now this is the required what so-called confidence level, and it's being written in percentage, 90% here. And so construct a 90% confidence interval to estimate the national mean gas price. So this national mean gas price right here is the value of mu. This is the population mean that was unknown right here. So now from our sample, the goal here is we would like to estimate this national mean gas price to be understood as a population mean value of that day. So I have to highlight that with this kind of problem, we can only estimate the national mean gas price on that day, because it's just the way how market is going. Gas price is changing every day. So the sample collected on this date can only be used to estimate national mean gas price on that day. Okay, and then of course we are using our sample. And this is the fact that was already mentioned throughout my general discussion lecture on how to find on confidence intervals. All right, so now turning our focus over to my writing board. Now I'm going to spend some time to quickly sketch down the given information, or just simply make a list of the given information. Our sample that we are about to use to construct the confidence interval is having sample size 36, as we had 36 gas prices randomly selected throughout the entire nation, really randomly. And from that sample, we found that we had for ourselves a sample mean calculated directly from this sample, being $1.69. And our sample standard deviation, the average spread on this sample of 36 randomly selected gas prices, was 0.25. Okay. Now, another piece of given information that's outside of our described sample here is that the problem asked us to find a confidence interval at given confidence level to be 90%. So as I was highlighting earlier on my computer screen here, we are looking at our goal here is to construct the 90% confidence interval. But so from that information, we extracted out that we have a confidence level, lowercase letter c, as I indicated, as I have mentioned in my general lecture. So confidence level is given at 90%. But then, just to be a little bit ahead here, but so that's the way how confidence level is being commonly indicated throughout our worded instruction of the problem, but when we actually later use it in the calculation, then this confidence level will always be used as a decimal. So 90% is better to be written as a 0.9 in decimal. Okay, so again, just as a clarification, 90% here as a percentage is the way how it's usually indicated in any worded description of our confidence interval problem. But when we're actually getting into the calculation, then we use the decimal expression of our confidence level. So 90% is the same as 0.9. And so now, after we're done listing down all of our given information, then again, recall from what I have mentioned in my general lecture, the idea of constructing any confidence interval, and here particularly we are constructing our confidence interval to estimate our population mean value. Then the final, in that way, the final confidence interval, and again recall that CI here stands for confidence interval. So the final interval must be in the form from where we found our sample value. So in this case, that's where we immediately going to start using our sample mean here. From where our sample value, in this case correspondingly the sample mean value, we must add and subtract an amount that we so-called the margin of error. And so I also explained the whole idea about what margin of error is in the general discussion or the general lecture about the confidence interval. So now the only thing we need to learn in this particular example that I have never mentioned this throughout my general lecture, that this margin of error now is going to be calculated using a formula as following. The margin of error is calculated by a value that I call the T sub C, and I will explain how to find that T sub C, and multiply with a fraction S over square root of n. And so, as a quick understanding for anyone viewing this video, S, the lowercase s here, is our sample standard deviation directly from the sample that I have described earlier. Capital N in our denominator here inside the square root is the sample size that we're using. And so, before getting really, and again, this is the actual formula to calculate our margin of error, how much we are going to add and subtract from our sample mean. This is the formula that we're going to be using to calculate our margin of error, how much we can add and subtract from the sample mean. And I have just now explained what S means and what capital N means. So all of a sudden we realize that pretty much our margin of error is almost ready, because we already had all of these values available as given information or as information that we can easily obtain. And so to get things a little more ready, I'm going to write E as, so the margin of error eventually need to be whatever value comes out for T sub C, which I still owe anyone viewing this video some instruction of how to find this. It will come. But now we're going to need to multiply, once we've had that T sub C, we're going to multiply with 0.25 divided by square root of 36. So that's just to give viewers a quick sense about how easy to find the margin of error here. And so now let me point out the instruction of how to find the T sub C. The good news for anyone is that finding T sub C in any confidence interval problem can be done as a fixed set of instructions. So here I'm going to give a general set of instructions, and it can be applied anywhere in any problem that requires a T sub C calculation. So how to find T sub C? And again, this lowercase letter c as a subscript here is intended to indicate that this T value we're finding is some kind of T value that's related to the confidence level given in the problem, and that's the whole idea. But then, as for our class here that we're learning, and as the intention of this video, it's aiming at to teach the direct skill. So to precisely explain what the t value, the t sub c value exactly is, it's gonna have to wait until anyone viewing this video arrive at a higher course in probability. I mean in statistics. But for now, we're just gonna simply look at the steps to calculate which t sub c value that can be used in our problem here. So the first step here, I am going to do the following. I'm going to go 0.5. It's just a value that we're always going to use, a 0.5. I'm going to add with half of our confidence level. So 0.5 plus half of the confidence level is to be the first step into finding our t sub c value. And so recall that as a direct work, now recall that our t sub c, and I have said earlier, we're going to use a t sub c, we're going to use a confidence level as a decimal expression. So here, getting really into the calculation, it's going to be 0.5 plus 0.9 over 2. And so calculation of mine came out to be 0.95. Okay, and for now, as we're just so that's completed our first step. But for now, as we just completed the first step here, this number is not telling us much yet. So now in step 2, we are going to figure out the degrees of freedom for our sample. So now again, I'm going to repeat. For step 2, we are going to figure out the degrees of freedom of our sample. Any sample with a finite sample size has a degrees of freedom. And so the rule of finding degrees of freedom. And for the rest of my lecture, anytime I'm looking at the degrees of freedom, I'll use the shorthand symbol df right here. So df, the degrees of freedom for any sample, is n minus 1. So we're calculating degrees of freedom by sample size minus 1. And so that means directly into our problem. For our current problem here, with the sample we are using at n equals 36 here, then our degrees of freedom for this sample is going to be 36 minus 1, which immediately gives us, without any need for a calculator, 35. So we have a degrees of freedom, the degrees of freedom here being 35. So now after having step 1 completed with 0.5 plus half confidence level giving a 0.95, and step 2 completed by giving us the degrees of freedom for our sample being 35 here, then now step 3 is where we're ready to find our final t sub c value. So now t sub c value is found by simply running a command on your standard calculator. I stick with the TI-8384 calculator, but know that outside of this calculator, there are other calculators that do the same work as well. So now let me give a snapshot of how we can find this t sub c value on the TI calculator. So now on my TI calculator, I am going to clear out this screen from our previous work. But now I'm going to run a command that's so-called invT. So to get there, second variables. And I'm going to navigate down to option number 4 that says invT. Okay, so again, second variables is to bring up the menu for all the distribution functions in statistics. But this time, instead of looking for other options as we have seen before, this time we're looking at invT to be used here. So I'm going to hit enter to select that. So now when we're actually at the menu prompt for invT right here, then when it's looking at area, then back on my work right here, the area we're about to give the calculator is this area. So this now has a meaning. This is an area, and sometimes some calculator is referring to this as left area. Okay, or simply for short, just area. So this is the area we're giving the calculator. And as I have mentioned briefly earlier, for our course here, we are not required to understand exactly what the meaning of the t value come from. So let's stick with the practical side of that. So we take this as the name so that we can communicate properly with the calculator. And then when you arrive at any viewer viewing this video when you arrive at a higher course in statistics, then you will get a chance to learn exactly what it means by being the left area and what exactly a t value is at your higher course there. But now 0.95 is the left area that we are going to provide to the calculator. And so now I'm going to, on the calculator screen, I am going to go to type in 0.95. And I'm going to come down to the next line right here by simply hitting enter or arrow down key right here. And so now this df here that the calculator is using is quite obvious. It's the degrees of freedom that the command is looking for. And so the command now is looking for the degrees of freedom. We already found that our degrees of freedom in our sample, the degrees of freedom in our sample is 35. So I'm going to give it 35 and then hit enter. Now our command is ready for action. So now I have to take a pause right here a little bit and explain a little further. But unfortunately, some early TI-84 calculators, after you select the invT, instead of seeing the menu like what you have seen earlier on screen, you will see a command directly like this being printed on your screen. And so if you're using those early TI-84 calculators, then you can just quickly you can just simply type in the command, the area value first after the parentheses here, then a comma, then the degrees of freedom, and close your comma. And that's making it look just like our completed command right now and ready for action. And so now I'm going to hit enter. So executing our command right here, our invT command, then this value after the calculation is the t sub c that we're looking for. And so back on my writing board right here, the t sub c that we're looking for was just a matter of running a program that's called invT. And that program, when we actually executing it, it's going to ask for two values. The first value that we must provide is the area left. And so that's what 0.95 is for. And then after that, we need to provide a second value, which is the degrees of freedom. And so if we really have to stick with the command, then that's how it is. invT as the command in parentheses. Put in 0.95 on your technology first with a comma, and then with the degrees of freedom. And we can close the command and now start hitting enter to get the final actual answer. So your final answer there, according to what you have seen on the screen earlier, is now going to be, unless being specified otherwise, and of course it is your responsibility to look for different rounding requirements in different problems you are working with. But usually throughout my lectures, I am going to be using 3 decimal places for my t sub c values. So 1.68. So it was 1.68957 and a lot longer. But now rounding down to 3 decimal as my plan here for this particular video, then we are forced to round down to only 1.69 right there. And that's our t sub c value. Now, I have to also mention another thing before I advance further into the problem. That sadly, your TI-83 calculator was a little too early. So stats was not too common. Stats work was not too popular at the time when TI-83 came out to market. And so consequently, when you go second variables, you won't see the invT functions provided in your TI-83 calculators. And so as I said, if you have a calculator other than the TI-83 or 84, I'm pretty sure, and as long as your calculator is modern enough, I'm pretty sure it will provide a similar function, and the way to operate is quite similar. But in case that you really are in a situation that you can only stick with your TI-83 and and you feel hesitating to obtain to afford for another technology just to do this kind of work, then I have two options for you. So one option is that you can search over the web for a video showing you how to manually program. You can actually program this function into your TI-83 calculator. So you can hop on the internet and say how to program invT on TI-83, and Google will give you a whole bunch of video lessons showing you how to program this command right here into your TI-83 calculators. Or over my years of teaching, I also developed a little bit of a program, a small program that's convenient for my students to be used, or for any viewers. And so it's just a simple Microsoft Excel that being developed as a program here. So let me quickly show that to anyone viewing this video, and it's meant for freely distributed. So anyone viewing this video can contact me to obtain a copy of this program. Alright, so now this is how my invT program looks like as a Microsoft Excel program. So for anyone who has obtained a copy of my invT program on the Microsoft Excel, then right after you run and to open your file, the first thing you see, there will be quite a few tabs at the bottom here. So the Microsoft Excel tab that you need to open is this tab that says invT right here. Now these other tabs are meant for other programs that are also used for statistics work, but not for that's not for the kind of material we're learning. So these are for a different purpose. So again, anyone using the invT program only need to navigate to that tab that says invT right here, and just simply disregard the other tabs. But now, just like how the invT program is ran on the standard TI-84 calculator, there's a box that's asking for, as labeled here, left area, and I made another box that's asking for degrees of freedom, DF. And so for our particular problem, so right here in this entry, in this cell right here, which is already highlighted, I am going to enter the left area, so 0.95, and hit an enter. And we can use our mouse cursor to click on the other entry right here, right underneath that label saying DF. So in that box right there, now I am going to just type in the degrees of freedom. So our sample had degrees of freedom 35. So this is 35, and now hit enter. So now, as you can start realizing that as we adjust these values, the value here has been changing. So this value is what I made Microsoft Excel automatically calculated. And this is our final T sub C value right here. And so having a closer look at this final T sub C value, it looks very much like the value that came out from our TI-84 calculator that I showed previously. And it's meant to be exact same thing. It's just the rounding is making the answer in Microsoft Excel looks a little shorter. Alright, and so now on the writing board itself, we all suddenly realize that our work to find the margin of error is ready, because we have just now found our T sub C value. So now we are ready. Margin of error is going to be calculated as 1.69 substituted for T sub C, and we will multiply with 0.25 over square root of 36 as one fraction. Your calculator, your standard TI-83 or 84 calculator, will be strong enough to handle this kind of calculation all in one step. So let me clear this out, and we can just quickly run the calculation here in one command right here. So 1.69, I am going to multiply. But for the guarantee of operations, I am going to use parentheses here and put my entire fraction inside of this parentheses. So 0.25 was my sample standard deviation that we saw on the writing board there. I'm going to divide that, and so now we need to put a square root. Okay, second square that brings the square root, and then now click 36. I'm going to exit out of the square root mode right here, and now I'm going to close the parentheses. So all that inside of the parentheses here is the expression for my fraction, and then this is the t sub c value that was in front, just like that. So the t sub c and all that here was that's how you saw on the computer screen how to enter that. And so now the actual value here, as I'm about to execute that command, is going to be 0.0704 and a lot longer. So now on my writing board, we found our margin of error. Straight out from the calculation, we've had 0.0704, 166, and a lot longer. But so now, in other problems, then again, as I said many times, it is your responsibility to look and to check for rounding requirements. But for this problem here, without needing anyone to tell you, anyone viewing this video should have a good sense about how far we should round this. It makes sense that this work we are doing here, the margin of error, in the end, it's money, because we're working with gas price. So for money, it's just the way how our nation is. We're gonna automatically round this down to 2 decimals. And so here my final concluded margin of error is going to be 0.07. So now we are ready to complete our confidence interval. Our final confidence interval. Now, earlier that was just a general sketch of what our final confidence interval needs to look like. But now, centering at $1.69 being our sample mean. This is the sample mean, the mean gas price in our sample on June 1st, 2020. But now the actual, the conclusion we have found now is that the actual national gas price, national mean gas price on that day is anywhere up and down by 0.07. And this confidence interval here is being guaranteed at successful level being 90% or 0.9, indicating that if we constructing our confidence interval like this on that day, 90% of chance this confidence interval will contain the actual mean value. So our actual mean value is going to fall within this estimation. So another way of seeing this is that, think of the 0.07 here, it is indicating only 7 cents. If we're looking at strictly in the money meaning, currency meaning, then on that day, the actual national mean gas price, guarantee at 90% chance successful, will be anywhere up and down by 7 cents from our $1.69 sample mean. And further, we can also do a quick little math, as I have explained in our general lecture. We can subtract this margin of error from our sample mean to get the low end of the interval. So 0.07 subtracted from $1.69 gives us $1.62, and that's the low end for our interval. If anyone really wants to look at the interval in what I so-called traditional format right here. And then if we now add this margin of error to the sample mean value in the middle, then we're looking at $1.76. So this now doing that adding and subtraction, the actual addition and subtraction work right here, then we come up with an actual interval. And a lot of time I refer to this interval as the interval in traditional format. Traditional format. It's the same interval format. And then again, so this now with the interval in traditional format being displayed here again, national mean gas price on that day, June 1st, 2020, is estimated to be somewhere inside of this interval between the low and the high ends right here, guaranteed at 90% successful level.